Hi, in this video, I will be showing you problem number 37 of chapter 14, section 2. Determine the set of points at which the function is continuous. F of xy equal to, it's a piecewise defined function defined as x square y cube divided by 2x square plus y square. If xy is not equal to 0, 0, and the second piece is 1, which means f of xy equal to 1, 1 if xy is equal to 0, 0. So we are going to show whether the function is, we are going to find out where the function is continuous. F of xy is obviously piecewise defined function. The first part of the function is rational and it is continuous everywhere except at the origin, right? Because the origin will make the denominator 0. So the first piece, f of xy, which is x square y cube over 2x square plus y square, is continuous for all xy except at the origin, which is 0, 0. Now, what is a concept? What do you mean by continuous? F of xy is continuous at any point AB provided the limit exists at that point and the limit is also equal to the value of the function at AB, right? So if limit of xy approaching AB of f of xy exists and it is equal to f of AB also. So this is the concept that we are using here in this problem. So this means that the function f of xy has a limit at AB and also the value of the limit and the value of the function at AB are the same. The limit of f of xy exists and it is equal to the value of the function at AB, namely f of AB. The two things must be satisfied. So we will do first, we will prove that the limit exists for this function by normally when we show that the limit exists, we use the squeeze theorem. So whether we can use squeeze theorem here and how do we apply squeeze theorem. And then the second part, we will see whether it is equal to the value of the function at AB or not. So does the limit of f of xy exist at 0, 0 in this case? So consider f of xy, which is x square y cube divided by 2x square plus y square. So now let's use squeeze theorem to prove the limit exists. So 0 is less than or equal to x squared less than or equal to 2x squared plus y square. So in order to use squeeze theorem, we have to actually look at the function. We have to connect a part of the numerator with the denominator and come up with an inequality. Because we need a three-sided inequality to use squeeze theorem. That's the idea here. So if we divide throughout by 2x squared plus y square, then you get 0 less than or equal to x squared divided by 2x squared plus y squared less than or equal to 1. Now, if you multiply throughout by y cube, because we need the numerator of the given expression, so we multiply by y cube and take the absolute also. 0 less than or equal to absolute value of x square y cube over 2x square plus y square is less than or equal to absolute y cube. In this step, we have only multiplied the previous inequality, three-sided inequality, by absolute y cube. And then now we will apply the limit as xy approaching 0, 0. So we get the left function and the right function will approach 0. So the middle function has nowhere else to go but to 0. Because the middle function, the mid function, which is f of xy, is squeezed between the end functions, namely 0 and absolute y cube. So limit of xy approaching 0, 0 of the function x square y cube over 2x square plus y square is equal to 0 by squeeze theorem. So the limit does exist for the function and it is equal to 0. Now the second part is this limit value is equal to f of 0, 0? That comes by the definition of the piecewise defined function. Now does this limit also equal to f of 0, 0 is the question, right? If you look at the definition of the function, the piecewise defined function, the second piece tells us that f at 0, 0 is equal to 1. F of xy equal to 1 for xy equal to 0, 0. So the limit value that we arrived in step 1 is not same as the functional value. So f is not continuous at the origin. It is continuous everywhere else. So limit of xy approaching 0, 0 of f of xy is not equal to f of 0, 0. This shows that the function f of xy is not continuous at the origin, but everywhere else it is continuous. So f of xy is discontinuous at 0, 0. So the question is, where is it continuous? So we say that f is continuous at all xy except at the origin, xy not equal to 0, 0. Hope this video helps.